Hi, it's Mrs. Cope, and today we're going to be talking about scatterplots. Our goal is to model data with scatterplots and lines of regression. Let's talk about what that means, and then we'll get into it. Scatterplots are real-world data. So up until now, or a lot of math, we use straight lines. We look at straight lines, we have different forms for these lines, and we act like everything just lies in a straight line. Well, real-world data does not fall in a straight line. Those straight lines are very useful because they can help us predict things, but when you start to plot real-world data, it often does not line up in a straight line. So you would get something like this. They're called scatterplots. It's the real data, and it's plotted just like ordered pairs, but they kind of splatter all over the place. They're scatterplots. So you can see general trends from this data, which is why our lines are important. But here we can see it's not all in a straight line, but whatever this relation is, and I would like you to think of something. Can you think of something as one thing increases, the other thing does too? See if you can come up with an example in the real world. If you could fill in the sentence, as blank goes up, so does blank. So if you think about that, this has a positive relationship. As x is increasing, this is a positive relationship. If I were to draw a line to model that, that would be a line of regression. That means it's a line that kind of fits the data and kind of shows me the story of the data. And this, of course, has a positive slope. So since it has a positive slope, it's a positive correlation. Here, as x increases, so we always read left to right, as x increases, y is going down. So we have a negative slope or a negative correlation. See if you can think of something that as one thing goes up, that makes the other thing go down. I'm going to look for some great examples tomorrow from you. And then here we have no correlation. Stuff is just scattered all over the place. They don't have anything to do with each other. So these two variables, whatever x and y are, they are not related at all. And so there's no correlation there. All right, let's look at one example here. And this would be households with the internet. I have my data here. So right here I have the years, 97, 2000, 2001, 2003, 2007. And notice they're not exactly like every 3 years. Real world data doesn't come that way. Sometimes they may not measure 1 year. They only do it during the census, or it doesn't always have to be every 3 years like usually they are in linear equations. And this is the percent of households. So 18% of households had internet in 1997, whereas in 2007, 61.7% of households had internet. So who knows what it is now? But that's a good question. What if we did want to know now? Or what if we wanted to, if we were an internet provider and we wanted to kind of say, wow, I want to get into this business. What's it going to be in 2050? Well, we don't know exactly, but we could use this data, find a trend, and then maybe we could put a line with that and use that to make predictions for the future. So if you have your scatter plot, this is just, I literally just plotted these points here. So that would be like, and notice here, years since 1995. So this point here is 2 because 1997 is 2 years from 1995. So I plotted 2 and about 18. So I plotted everything on here. And what we want to do is find a line that fits this data. Now your line might be different than my line. It might be different than your partner's line. So we just want to say, let's get a line that kind of fits a lot of the data. That means, let's say a little bit is above, a little bit is below. We want it to kind of be in the middle. Now your line might be slightly differently sloped. You might have gone through 2 different points. Either way, there's still lines of regression. They still can help us to predict what would happen later. So we want to write the equation for this line so that we can use this to predict what will happen in 2050. And we're going to use point slope. This is a review. We've already done point slope, so I'm going to go through it pretty quickly because we've already done this. But you have 2 points on the line. You have a few, but on my line that I chose, I have 2 points, 5, 41.5, and 12, 61.7. So we're going to use these 2 points and use point slope form like we have before. First, you'll want to find your slope, y2 minus y1 over x2 minus x1. Of course, we're going to do that. This will be x1, y1, x2, y2. And once you find your slope, your slope should be about 2.89. So you have a slope and you have a point. You have 2 points. You can choose whichever one you want. And then we would do point slope. Y minus y1 is equal to m times x minus x1. So I've written it out in point slope form. You could leave it that way. It's not very simplified. I wouldn't prefer to see it that way. I would go ahead and simplify it, distribute, and make it in slope-intercept form. Again, if you don't remember that, we already did a video on that. You can go back to it. But it should end up being 2.89x plus 27.05. Now we have a line that we can predict. We can use this to predict later years. That's the beauty of finding a linear regression. It can be used to find information for later. So if I wanted to find out 2050, why don't you do that? Tell me what percent of households using our line would have the internet in 2050. Don't forget, X is the number of years since 1995, so you need to calculate that first. Come in and let me know, and let's see if is it a realistic number? May not be. It may be, this line may not be the best line to fit the data, but come in and let me know what you find out tomorrow. Again, thanks for watching, and remember, you are responsible for your own learning.